Okay, so on this one, it says, suppose that you have 9 cards. 4 are red, 5 are purple. The cards are well shuffled. You randomly draw 2 cards with replacement, meaning you're putting back the first card. All right. R1 is first card is red, R2 second card is red. Okay. What's the probability of R1 and R2 and probability of at least 1 red? It's a little confusing. Okay. All right. So let's think about this. So we have 4 red, and what's our R1, R2? What's our one? First card is red, second card is red. Okay, first card is red, second card, and they want R1 and R2. Okay, so let's list out the cards. So I have a red 1, a red 2, a red 3, and a red 4. And then we have these purple. 5 are purple. So purple 1. It doesn't say the numbers, but whatever, I'll just pretend they're 1, 2, 3, 4, 5, whatever. So 4 red, 5 purple, right? And but you're drawing out 2 cards with replacement. What does that mean? You replace, you draw 1 card, look at it, replace it with replacement. You put it back in the deck and draw a second card. So you could get the same card twice, in other words. It's possible, right? You're putting back the first card. Okay. So, so the question is R1 and R2, and then at least 1 red card. Okay, yeah, this is tricky. At least 1 red card. Yeah. Okay. So here's the trick. Couple things we've learned from probability. And so the first, I'm going to do this and question. Whenever we have and, we multiply each of the events together. So, like if I said, what's the probability of getting heads on a coin? What's the probability of getting, if you're going to flip a coin, heads? Yeah, I think you all know it's half, right? 0.5, 50%, half. So what's the probability of getting heads, the first one heads, and then flipping it again, second time, and getting heads again? Well, it's going to be a half times a half. My point is, and means multiply, and the answer would be 1/4. It makes sense. It's a lower chance, right? It's harder to get 2 heads in a row. It's more rare. So you multiply. So whenever you have probability with and, you multiply. So let me make note of that. That's our first question. Let's write this down here. Yeah, in fact, I'm going to need some more space. So let me just squeeze in some space here. Okay. So probability, red 1. What is it? First card red, second card red. Yeah, red. The first card's red and the second card's red. Right? That's what red 1 means. Means first card comes out red and second card drawn comes out red. So it doesn't mean card number 1 or card. It means the first card you draw is red and the second card you draw is red. Okay. Well, how are we going to do this? It's going to be multiplied. It's going to be the probability of red 1 times the probability of getting a red on the second draw. And is multiply. So that's an important fact to know. With probability, and is multiply. Okay, so what's the probability we're going to get red on the first card? Well, how many cards are red? 4 out of 9, right? You with me? Probability of getting a red card is 4 out of 9 because there's 9 cards total and there's 4 red, right? Remember, it's the number you want. We want red. There's 4 red out of 9 total. So the probability of getting red is 4 out of 9, and the probability of getting red the second time is the same thing because we replaced the card. It's the same exact group of cards second time. So you multiply those together, you just multiply straight and straight. 4 times 4 is 16, 9 times 9 is 81. And do they want to, yeah, they want a decimal to 2 places. Divide that on your calculator. And I'm getting 0.1975. They say round to 2 places. Cut it right here. The 7 says round her up. How do you round up 19? 20. 0.20. So there'd be a 0.20, a 20% chance. In other words, if you change the percentage, we're not going to change the percentage. But that's the same as saying there's a 20% chance you're going to get red on both cards, red on the first card and red on the second. So that makes sense, and is multiply for probability. It's multiply. Probably red the first time and red the second, 4/9 times 4/9 comes out to 0.20, 20% chance, okay, or 0.20 decimal, same thing. Now, second question is more difficult. Probability at least one is red. All right, that's harder. Now, we have something in the notes on that. Let me grab it from the notes. You want to print out these notes if you have not. They will be a big help. It's great to have them printed and sitting right in front of you because it'll really serve you well. There it is. There, you see it right there. Let me pop it in and we'll look at it closely. Right there it is. And here it is. Here's at least one. I'm telling you how to do at least one. What do? The answer is going to be 1 minus naught, whatever they're saying, multiplied together. 4 children, they said, what's the probability? At least one girl. It's 1. That's important. Don't forget that 1 minus not girl times not girl times not girl times not girl. Now, they did 4 times. Why did they do 4 times? Well, because they were saying 4. But if they only said 2 children, they would have only had 2 of these. Does that make sense? Or 3 children, they would have had 3 of these. So that's the formula. So go back up there to this. Where is it? Right there. All right. And let's do it right here. At least one red. And we're drawing 2. So it's going to be 1 minus not red times not red. 2 times. Why 2? Because we're drawing 2 cards, right? You randomly draw 2 cards. So you've seen how I came out. I'm going to work that out, but you see how I came up with that formula. When you do at least one, as it says right here, it's 1 minus not whatever they're saying. In this case, it was, having a girl. So it's 1 minus not that, multiplied together that many times. And you might, I don't want this to be magic. Why? Why is this formula right? Well, because having at least one red, what's the opposite of it? The opposite of at least one red. At least one red means one or more reds. That's what it means. At least one means at the least, at the lowest, one, maybe more. So at least one red means you get 1 or more reds. Well, what's the opposite? The opposite is getting no reds, right? The opposite, if you don't get 1 or more reds, if you don't get 1 or more, then you got none. And what's the probability of that? Well, not getting a red and not getting, the only way you're going to get no reds is if you don't get a red and, remember, and is multiply, you don't get a red. That's why I'm telling you the formula is not red times not, because that means the chance of not getting a red at all. And then we do 1 minus. Why? Because we want the opposite. The opposite of not getting a red at all is getting 1 or more reds. Do you see how this is the opposite of getting no reds at all? It's 1 minus. Remember, 1 minus is always the opposite, like rain and no rain, 1 minus for decimals. It's the opposite, 1 minus, of getting no reds at all. Getting 1 or more reds is the opposite. All right, I've said that enough. Hopefully it's sinking in. So what's the chance of not getting red? Well, look up here. The probability of not getting red is going to be 5 out of 9, because there's 5 cards that are not red, meaning they're purple, out of 9 cards total. So anytime you reach in that deck, if you want to not get red, you have a 5/9 chance because 5 out of 9 cards are not red. So 1 minus 5/9 times 5/9. So just literally type that into your calculator. 1 minus 5 divided by 9 times 5 divided by 9, and then hit enter at the end. Literally type that in just like that, and it'll give you the answer, which I'm doing right now. And I'm getting.
Wait, do we have to put it in parentheses?
No parentheses needed. 0.69135, round to 2 places. So it'd be 0.69, like that. Did I answer your question? That you don't have to do anything on the calculator with parentheses, is what I was meaning. Just type it in straight. 1 minus 5 divided by 9 times 5 divided by 9, hit enter at the end. How are we doing? Can I help with anything on this number 5? This was a harder one. There's two morals to this story. And always means multiply. And at least, you got to use the at least formula from the notes, which is 1 minus naught times naught, however many times, in this case, 2 cards, 2 times. How are we doing? Can I help with anything on your version of number 5? Are there a lot of differences out there? Good. Any questions I can answer? All right.